Pre-Algebra Lesson 102, Adding Like Terms, Part 2. So, in our first Adding Like Terms lesson, we learned how to add terms like this, that have the same variable, right? And they have to have the exact same variables, okay? So, for example, why does this seem out of focus? What's happening here? Okay, that's a little bit better. Hopefully this is good enough for you guys to be able to see at home. No, my focus is already. Oh, nope, wrong. Maybe if I set it to 1, nope, 2, 3. I think that's as good as it gets. Okay, anyways, so what we had terms like this. We had 4xy plus 6yx. These are actually the same term, okay? Because they have the same variables, they're just written in the wrong order. Okay, so 4xy, 6yx, those are the same thing, okay? What happens if I start changing the exponents, okay? What if I did something like this, and zoom back out now. What if I had 4x squared y plus 6xy? Are these the same terms? They're not, actually. Okay, so not only do we need to have the exact same letters for terms to be equal, we need to have the same exponents. And right now, this x does not have a squared. So these cannot be added. They are not like terms. So in order for things to be like terms, you got to have the same letters and the same exponents. Letters, those are good. Exponents, wrong. Okay. Now here's another thing. Sometimes you'll see something like this. You'll have 4x squared plus 6xy squared. Are those the same? No, they're not, right? So before, these y's both had an invisible 1. That checked out. Now, this one has an invisible 1, this one has 2. Not okay. And then the x's, this x has 2, this one has an invisible 1. The exponents have to be the exact same for each letter. So, to have like terms, we would need something like this. Like if I had 4xy squared plus 6xy squared. Those are like terms, okay? Because each letter has the exact same exponent as its counterpart. Now, if you remember when we add like terms, it's almost like adding fractions in that the denominator doesn't change. When we're adding like terms, the variable in the exponent doesn't change. So when I do 4 plus 6xy squared, the answer is just going to be 10xy squared, okay? Now let's go to an example problem, because these problems can get really tricky, okay? Let's do, here's a good one, okay? So we've got x times x plus 3x squared times x plus 4x cubed plus 2xy minus 3yx, okay? Now, there are some issues with this problem. The first one is I need to use my algebraic powers of rewriting. None of these, not none, but a lot of these terms are not simplified, okay? Now, in order to make adding like terms easiest for yourself, you should combine all exponents and write all letters in alphabetical order, okay? Now, your book doesn't always put them in alphabetical order. That's a rule that I use because it helps me. If all my letters are in alphabetical order, it's easier for me to see that these last two terms are the same. So step 1, I'm going to rewrite the entire problem as simple as possible. So instead of writing x, I can just write x cubed. Then this, 3x squared times x. Well, if I remember my exponent rule, that's an invisible 1, but they got the same base, so I can rewrite this as just 3x cubed, okay? 4x cubed, that one can't change. That's as simple as possible already. And then 2xy, that one's already in alphabetical order. There's no exponents to change. But 3yx, I can rewrite that in alphabetical order. I'm going to rewrite it as 3xy. Okay? And that makes it easier for me to see that these two are the same. Okay? So don't neglect that alphabetical order. It's very, very helpful. Okay? Now I'm just going to mark my like terms. Put all the x cubes in circles. And then I'll put all the xy's. I need to remember to add the sign in front. Whoops. Okay, so let's add up the x cubes. So again, remember this one has an invisible coefficient of 1. You got to watch out for those invisible ones in these problems. So I've got 1x cubed plus 3x cubed. Let's see here, that's 4, and then 4 plus 4x cubed, that gives me 8x cubed in my final answer. Now I'm not done, I need to add the xy's. So 2 minus 3, positive 2 plus negative 3, that gives me negative 1xy. And I don't actually need to write that 1. I can just write negative xy, and that 1 can stay invisible. So my final answer is 8x cubed minus xy. Okay? So again, it's very, very important that when we solve these problems, we rewrite them first and then start adding like terms. That's it for this lesson. If you guys have any questions, let me know on the school website, and I will see you in class.